Hi, I am Ashish here and welcome back to the Coders Academy channel. Today, I'll show you a super quick demo of the LangExtract library, a tool that allows you to pull structured information from plain text using AI. In this demo, we will extract information from product reviews so that we can predict the product ratings, the sentiment of the review, and some of the key features that is mentioned in the review. We begin by setting up the project, installing the libraries, and creating an AI prompt so that we can tell exactly what information to extract. And then we provide some examples so that the AI model can understand what we expect. And then immediately LangExtract gives you the information in your desired format. So without further ado, let's jump into today's video. But before we get to the demo, make sure that you watch the video till the end, because if you miss the steps, it will be very difficult for you to come back on track. And secondly, all the code that we do in this particular video will be available on my GitHub repo. The link to the repo will be available in the description box. Now let's take a look at the GitHub information about the LangExtract library. So I've gone to github.com, LangExtract, this particular URL. So it says here it's a Python library for extracting the structured information from unstructured text using LLMs with precise source grounding and interactive visualization. So it gives you visualizations also and precise source grounding. I think this means like it can trace the source from where the information was extracted. So the library is available under the Apache 2 license, which is good. So we know that it's a Python library to extract structured information from unstructured text documents based on user-defined instructions, and you can use LLM for doing that activity. Now it processes the material such as clinical notes or reports, identifying and organizing key details while ensuring the extracted data corresponds to the source text. Now, why do we need this library in the first place? So it maps the key every extraction to its exact location in the source text. So that is what the meaning of source grounding is. So you are able to extract the information and also map it to the relevant source, so that it helps you with the easy traceability and verification. It enforces a consistent output schema with the help of the few short examples. So in your LLM prompt, you can also provide some sample examples, which is called as few shot prompting, and with the help of which you can extract the information from the unstructured data, and you can use models like Gemini to guarantee robust structured results. Now you can also make use of this for extra long documents, because the library is optimized for text chunking and parallel processing. It provides you interactive visualization in the form of an HTML file. Then supports preferred models, which could be your cloud-based models like Google Gemini, or you can also have it run locally using frameworks like Ollama and Yarn. Okay. If you haven't checked my videos on Jan and Ollama, have a look at the library on the YouTube. Yeah, so then here are the steps on how to get started with this particular assignment, where it can you can make use of the Gemini API key, which you can create for yourself. It actually starts with the process of installation, which is here. So you can use pip install LangExtract. In our assignment, we will be using UV, that is the fastest package manager, so we'll use that. And then you can set up the virtual environment, activate them, and things like that. You could also directly build it from the source. You can use a Docker container and Docker image. Now let's come back to the code per se. So here is a sample code that they have given for extraction of the text. So here is the library, text wrap, the prompt, and here is the examples of the few short examples that we were talking about, right? So there is a text called Romeo but soft, what light through other things, etc., etc. And then the extraction examples are given here. So extraction class character, the text is Romeo, what are the attributes for emotional state, feeling, and type, etc., right? So these are the examples of few shot prompting. Then for running the extraction, this is the way you can do it. The input text is given, and then you can say LX.extract. The input is given to that, the prompt is given, examples are given, and the model name is given. Finally, you can complete your assignment by having the results visualized in the form of HTMLs. So what you can do is lx.io, save annotated document. You can pass the results to it. You can provide the name of the output file, JSON-L, and the directory. And finally, an HTML content can be generated from that JSON-L file. And here is how it will look like for the example: character, emotion, relationship, class, and attributes, and this is how it is going to display. Yeah, now let's take a look at the demo that we have created for LangExtract. So we'll start with the project setup. I have a Windows PowerShell window open here. Okay, so we'll start with the usual process. So we'll say cd projects. We'll create a new directory called demo lang extract. We cd into this directory. Okay, now we do a UV init. If you haven't installed UV, you will have to do that. Please check my earlier videos on the steps to install UV. So UV init will initialize the project directory that we have here. Now what we have to do is we have to add the dependencies. So let's do that. So we will add the dependencies for LangExtract, Google Generative AI, and Python.env. Google Generative AI, we require this so that we can interact with the Gemini models. LangExtract is the library that we will demo today, and Python.env we require so that we can read from the .env file the API key of the Gemini model. So enter. So let's wait for the dependencies to get installed. Done. Okay, now we will open this project demo LangExtract in the VS Code. This is the project that we have got created here using UV. So you can check here the libs folder. This has all the dependencies here, but better if we can check the project toml file. So this is the project toml file, name of the project, version, any description that you wish to add, what is the base version for Python required, and the dependencies. So we added 3 dependencies and we can see them here. Before you get started, you make sure that you have the API key for the Google Gemini model that you will have to enter in a .env file that we will create here. So I'm creating a .env file here, and this will contain our Google API key. You will have to paste your API key here. Okay. In our first demo, what I have done here is I've created a file called demo.py, which is exactly same as the code that is shared on the GitHub repository from LangExtract. Okay, so we start by our usual imports, where we import the LangExtract library. There is a .env that I have used to read the property from the env file. So here is our API key. This is the key that has been mentioned in the .env file. Now the first step we have to do in LangExtract is to define the prompt and the extraction rules. So here is our prompt. The prompt says extract characters, emotions, and relationships in the order of appearance. Use extract text for extractions. Do not paraphrase or overlap the entities. Provide meaningful attributes for each entity to add context. Then what we do is we provide some examples for the prompt. Now here is the example of few shot prompting. Here in this case, what it has done is we create an example data object where we provide a sample text. This should be a high quality example so that we can guide the model for extraction of data. So here the sample text is Romeo but soft. What light through yonder window breaks? Is it east? And Julia is the sun. Now the extraction rules have been defined here. So what is that? So we have an extraction object where we say the extraction class is character, the value will be Romeo, and the attributes will have something called as emotional state of wonder. The second extraction is emotion, and the text is soft but soft, here it is, and the feeling will be gentle awe. Relationship, the text will be Julia is the sun, and the attribute will be a metaphor because Juliet is getting compared to a sun. The next step in the assignment is to basically provide the input text that you want to process. So here the input text is Lady Juliet gazed longing the stars, her heart aching for Romeo. Now the next step is to run the extraction process. So here we have lx.extract. We provide the text or document as input. In this case, it is the input text. The prompt description, I have provided the prompt that we defined in the first step. Then we give the examples for few shot prompting. So here is our examples. The model ID, I am making use of the Gemini 2.5 Flash. You can use the model that you want. You can also make use of OpenAI or other models. Then I provide the API key that we extracted from the .env file. Now as the next step, what we do is we just create an annotated form of the result from the LLM. So we have something called as save annotated document. We provide the result as the input to it. The name of the file should be extraction results.jsonl, and it should be there in the current directory. Now the final step is to generate the visualization for the file. So I have here HTML content, we give the annotated file as input here, and then we open the file and write the HTML content. Now we'll run this particular demo file and let's see what output it gives us. So 68 characters processed. Now the file that we should look at is the visualization HTML. Okay, so this is the file. This is what the file looks like. You can have a play button here. So it has highlighted the legend as character, emotion and relationship. If you see, these are the three extraction rules we had defined in the Python code. So if you go up here, see here. So the extraction class is character, emotion and relationship. Character, emotion and relationship. And now when you play this, and this is the input text that we had given, right? Lady Julia gazed longingly at the stars, her heart aching for Romeo. So we play this. So it is highlighted what exact emotion, character and relationship it found from the input text. In the second demo, I have something called as a review analyzer. Here what I am trying to do is I am trying to evaluate the product reviews for a products. So my prompt is extract sentiment with the confidence level, give the predicted star rating, recommend whether the product will be recommended in the review, and some key themes in the order of appearance. Use the exact text for extraction, do not paraphrase or overlap the entities, provide meaningful attributes for each entity, and sentiment should be positive, negative or neutral, and predicted star rating can be from 1 to 5. So 4 informations, okay? The sentiment of the review with the confidence level, a predicted star rating, recommends the product and key themes. Now I provided a high quality example to guide the model. So here I have some review that I have already added here. I bought this wireless headphone last month. I'm really impressed. The sound quality is excellent, especially the bass. Battery life lasts about 20 hours, which is perfect for my daily commute. The only downside is that there's a bit of heavy after wearing them for 3+ hours. Overall, I'll definitely recommend these to anyone looking for a good value wireless headphones. Okay, so it does capture all the extraction rules that we mentioned here. Now let's define our extraction rules. The first one is I want the sentiment, and in this case the sentiment is clearly positive, so that's what I have added as a value. The confidence level is 0.90. I have just picked up a random value for confidence based on this review. Then next is a predicted rating, 4 out of 5 stars. A recommendation of the product, yes, because here it has mentioned that I will definitely recommend this to anyone. Key themes is sound quality, battery life, comfort and value. So these are the sound quality, battery life, comfort and value, right? Now as a next step, I have a new review which I want to evaluate based on those 4 extraction rules. So the input here is terrible experience with the laptop. The screen started flickering. Customer service was unhelpful. It took forever to respond. The keyboard feels cheap. Several keys are stuck. For the price I paid, I expected much better quality, save your money and look elsewhere. Now clearly based on this input, the review is negative. The recommendation will not be there. I mean, if it is there, it will be just a 1 out of 5. Then based on that, what we'll do is we'll run the same process again. This is the input, the prompt, the examples, model is the same, API key is the same. Now for the convenience, what I have done is I have saved the annotated results in a file called reviews.jsonl, and finally I have visualize that particular annotated document as review visualization.html. Okay, now let's try to run this and see what output we get. So the code, if you notice, it's exactly same as what has been mentioned on the demo.py. So here what I'll say is uv run review analyzer.py. Completed the extraction process. Now let's take a look at our HTML file, which is reviews visualization, this file. Okay, so here there is a problem. So it has identified only one extraction rule, which is key themes, and on the basis of that it has identified that key theme as screen, though it should have been many other things here. I'll hit the play button. There's nothing there because there's only a single theme, so there's no playing that is happening where screen is changing and things like that. Okay, so when I looked at this, I think it's not working well for all the use cases and examples. Let's take a look at it more closely. Okay, so when I looked at it, I see that there is a problem with this particular file called reviews.jsonl. So here if you see the extraction class sentiment negative, so it has identified that the extraction class is negative. Then confidence level is 0.95 because the review was not positive at all. Predicted rating, it has said 1 out of 5 stars because it was not very positive. Then recommends the product, clearly no, because the rating itself is 1 out of 5. And themes, right? Key themes. So in the key themes, it has identified screen quality, customer service, keyboard quality, build quality, value for money. So there are so many parameters that it had identified correctly, but it is not showing in the HTML. So when I looked further down, I realized that there is a problem in the way this annotated JSON-L gets generated from the LangExtract library. So if you look deeper, you'll see that the character interval is null, alignment status is null, and that is the reason why you do not see the HTML populated correctly. So the AI model, the Gemini model, has correctly identified the extraction rules, but the HTML does not show them correctly in the browser. That was your demo for today. We looked at the library called LangExtract by Google, and we saw 2 demo examples using that same library. It worked very well for the first demo, but for the second demo, I think there are some minor errors that the team needs to fix. Once those issues are fixed, I think the library has a lot of potential in many applications that we see today. If you like the content that I have been making, do not forget to subscribe to the channel and like the video. Do let me know in the comment section what is the next video you would like to see. Thank you so much for watching.